In addition to addition, subtraction, multiplication, and division, we're going to have to start doing exponentiation with variables in algebra. Now, let's go back to multiplication. Multiplication is really multiple addition. Yes, it is. 5 times 3 is really 3 5s added. That's where the 3 comes from, but it is multiple addition. Now that's very different from exponentiation. Exponentiation, we put the 3 up here, and the 3 still has a say. It's just not multiple addition, it's multiple multiplication. And 5 times 5 times 5 is certainly not 15. It's a much higher number, 125. Now let's start doing it with numbers first, because letters represent numbers. Let's look at 2 to the 4th power. Don't even think of 8. That's going to be 2 multiplied by itself 4 times. Now you have to do a little bit at a time. 2 times 2, we get an answer of 4. Now take that answer, multiply it times 2 and get 8. Now take that answer, multiply it times 2, and guess what? The answer is 16. Let's do another. Let's try 2x, let's throw in a letter, to the 5th power. Now this one's a little bit weird, because that 5 only has power over the x, doesn't it? The reason for that is the order of operations says that exponentiation between the x and the 5 has to occur before the multiplication that's between the 2 and the x. So you have to write 5 x's, and then actually you only have 1 2. That 5 only has power over the x's, unless we have a situation where we have parentheses. Now those parentheses add power to the 5. That means we're going to have this 2x 5 times. The whole thing is 5 times. Okay? Let's try another. How about multiplying 3 to the 2 power times 3 to the 4 power? I want to show you something that's going to happen here. 3 to the 2th, if you would, just means 3 times 3. There's 2 of them. And 3 to the 4th means 4 of them, doesn't it?
Is that your final answer?
Isn't there 6 of them? Well, we could go 3 times 3 times 3 times 3 times 3 times 3 6 times and get 729. Well, what I'd like you to note, where is there a shortcut where that 6 came from? Between 2 and 4. Think about it. Well, there is a rule for this, a shortcut rule if you would, and it's called the first rule of exponents. There are 2 rules, so this is the first rule. X to the a times x to the b. If I have 2 expressions with the same base and I multiply them with exponents, what I'm going to end up doing is adding the exponents. For instance, we just did it. 3 to the 2th times 3 to the 4th is the same as 3 to the 2 plus 4, or 3 to the 6th. This is going to save you an awful lot of writing. T to the 15th times t to the 12th.
Holy alphabet.
That's a lot of letters. What's the answer going to be?
Genius. That's what it is. Sheer genius.
T to the 27th, because 15 plus 12 is 27. Get the idea?
And now something completely different.
Now I need you to see here that what we have is not 2 expressions multiplied. So this is not going to use the first rule of exponents. What we have here is an expression, x squared, raised to another power. going to be done completely different, but we will have a shortcut. Note that we've raised x squared to the 4th power, so we have 4 of them. 1, 2, 3, 4. Now if we want to, we can spread those out. Recall that x squared means x times x. And of course the other blue x squared, the green x squared, and the purple x squared. Now we could, if we wanted to write them out like this, we could just do that and count them, and you would get x to the 8th. But let's try to come up with another shortcut rule for exponenting exponents. And that's going to be the second rule of exponents. X to the a to the b is going to be x to the a times b. For instance, as we said, x to the 2th to the 4th, rather than write it all out, which you can do if you get confused, is going to be x to the 8th. That's really going to save us a lot of writing in a situation like this. Think of all the z's you'd have to write. You might fall asleep. This answer is going to be, that's a nice shortcut. But you'll have to remember the difference between this first rule of exponents that uses 2 terms multiplied and the second rule of exponents, which is really 1 term raised to a power. One other thing you're going to need to know about this second rule of exponents. Let's take a look at this problem. 4x quantity to the 3rd power, of course, means 3 of these 4x's. So what's the answer going to be? Well, we'll use our rule, the second rule. We know that the x is going to be x to the 1 times 3, if you would. There's a 1.
I know that, dude.
Okay? What are we going to write for the number? That 4, is that 4 an exponent? It isn't. Those 4s are, I don't want to say numbers, but they are. They're certainly not exponents, so they don't follow the rules of exponents. We're not going to go 4 times 3. They're not exponents. They're what we call coefficients. They follow the regular rule of numbers. So we'll just have to go 4 times 4 times 4 and get 64. Okay, so just remember that your coefficients don't follow these rules of exponents because they're not exponents. Let's just remember these 2 rules. The first rule of exponents is when we're multiplying 2 expressions with the same base, we can add the exponents. The second rule is when we're exponenting one expression, the shortcut is to multiply the exponents. Okay?
Does everybody know what time it is?
It's homework time. Let's get busy.